Right, so we will start with the introduction to Python, and we will look at what all common development environments we use in today's world, and then we will look at installation of Anaconda distribution, right? So by now, you should all have clicked on this link and should have started the download process, right? So you should have clicked on ideally, depending on your computer version, 64-bit or 32-bit, and it should have started the download of this file, Anaconda version, uh, whatever Windows version .exe, right? So if you're already done with this process, then you will see something like this here. Okay, all right. So that is done. What we can also do is simultaneously start looking at how to actually open the file that we had earlier downloaded, right? Which is this Python introduction workbook. So we had already downloaded Python introduction.ipynb file, right? Let's look at how to actually open this, right? So we have not gone through this so far as to what are the common IDs that we have, but what we will do is we'll first open one of these IDs because this file that we have downloaded is going to be opened in Jupyter Notebook. So we will, since I have already installed Anaconda, I can start Jupyter Notebook, and that is what I'm doing right now. So to start Jupyter Notebook, I can just search for Jupyter and then click on Jupyter Notebook. It will open a Jupyter console. One thing that you should note is you should not close this. You can just minimize and leave it running, and it will open a Jupyter Notebook console inside a browser, whatever your default browser is. So what you can do is, since everything goes into the downloads folder, I can go to downloads here, and then from here I can search for the file which I had downloaded, right? So this is the file which I had downloaded, Python introduction.ipynb. So I'll just click on this and I'll open. So just to let you know again what this file is, this is the same file which I have downloaded from here. So this is exactly what you need to do. You first download the file and then open Jupyter Notebook and then browse through the file and open this file. Now we are going to share multiple Jupyter notebooks with you. And why so? Because Jupyter Notebook, I'm assuming that most of you have heard about it by now, is one of the most common IDs which is being used these days. The reason it has become very popular is it opens inside a browser. It is very easy to use. It is very friendly to use, and if you really want to share code with others, then it is by far the easiest that you can use to share code, right? How did I share this code with you guys? If you look at it, I just uploaded a ipynb file. So ipynb is Python notebook.
But
Yeah, and
I'm
you can just
key
go ahead.
conversion my dashboard.
Sorry.
I just open it, click on courses, and I'm saying that no module has been defined for this course.
Okay. Who is this? Can you is this Gajinder? Who is having this problem? Not able to see the dashboard? Gajinder?
That is, yeah,
Okay.
Me also.
It says no module has been defined.
yeah.
Yeah.
Okay. Let me check through that and I will get back to you guys. I think. Okay. Okay. I will need to fix this. So let me work through this. I will need to fix this. I think it is not configured correctly. I will correct this and I'll let you guys know. Don't worry. And you should be good with this. Uh, okay, all right. Thanks for letting me know. I will fix this and I'll let you guys know so that you can use it. So you can just download it from here. you can refer it from the video itself, and then this is how you can use it, right? So till the time Anaconda gets downloaded for you, what we can do is quickly go through the introduction, right? So, as most of you may be knowing already, Python is an interpretable language and it is an object-oriented language as well. Uh, when we say we're not going to, look at the whole definition of it, but then there are a few key things that we should definitely know, and that is what we are going to actually touch base upon. So Python is interpreted, right? What does it mean? You may have known, right? There are these languages which are called compiler-based languages, and then there are these languages which are called interpreter-based languages, right? So Python is an interpreter-based language. So what happens is before you execute the before you actually execute any program written in Python, you do not need to create an exe file, or you do not need to actually compile the code. You can just execute the code, the lines of code that you write, and this is what Python does. Uh, it's the same kind of a environment in which Java runs as well. So Java is also a programming language which is interpreter based. But when it comes to C or C++, you can say that that is compiler based, right? Before you, if you have ever coded in C or C++, the first thing that you do after writing the program is you first compile the code, which creates the machine understandable format of the code, and then you can actually go ahead and execute that code. So C and C++ are examples of uh, languages which are compiler based. Now Python and Java, for that matter, is interpreted, right? So what happens is when you write a code in Python, then you do not necessarily need to compile it, right? You can just execute it. So you must be thinking, right? If there is no compiler, then how does the machine understand the code that you have written in Python or in Java? Um, what happens is there is something called as an interpreter, which is working behind the scenes, right? So what it does is, what the interpreter does is, it actually interprets the code in the runtime itself, and then converts that into machine language, and that ways the program executes in the runtime itself, right? So think of it this way: you're not compiling the code, you have an interpreter which is available to you, and that interpreter actually converts the code during the runtime itself into the machine language, and it executes in the runtime itself. So can you think of and let me know which of the two languages is going to execute the code faster or slower? So if I compare Python with, let's say, C, uh, a program written in C will execute faster, or a program written in Python will execute faster? Anyone?
Or Python will run into faster.
Python will run faster. Is that what you said?
Yep.
What about others?
Yeah, Python.
Python will run faster.
Yes,
But why do you think so?
because we don't need to compile, as you said. We can directly execute.
Right, but then can you okay, so when you write a syntax in Python, right, or in any programming language, then it is mostly English like, right? You write if, you write else, you write for, right? These are all syntax, part of the syntax, but then these are mostly English statements, right?
Yeah.
does your does your CPU, does your computer understand these syntaxes the way you write them? Is
No,
what my question is. It does not,
no,
right?
no.
So there has to be a conversion, right, from the syntax, the way you write it, to how the computer understands it, right? It
Yes.
has to happen, right? There is no other option. Now what happens in terms of a compiler is, after writing the code, it is converted first into a machine understandable form. That is what we are calling as a executable file or a exe file, right? And once that is done, you execute the whole exe file on your CPU, and that is how your program will run, right? But what happens in case of a Python, we do not create the exe. we do not create the executable file. The interpreter in this case will keep reading one line at a time, convert that into machine interpretable language or machine understandable language, and will keep executing the lines of code. So what it means is that if your program has 10 lines, then Python interpreter will first interpret the first line and execute it, then move to the second line, then convert that into a machine understandable form, and then execute it and keep doing it for the rest of the lines of the code. Getting
Okay.
that? So
Yeah.
the flip side of it is, and this is actually true, that a program written in Java or Python is going to execute slower than a corresponding program written in C or C++. Understood?
Okay. Yes.
Yeah,
Yeah.
and the reason is that, somebody, the in this case the interpreter needs to actually do that conversion on the runtime itself, right? On the runtime itself means when the program is executing, it is being interpreted simultaneously as well, because the conversion into machine language has not happened earlier, right? And that is why a Python program is going to execute slower than a corresponding program which is compiler based. So that is one of the features, and there's no right or wrong thing about whether a program, or a programming language is interpreter based or compiler based. These are just differentiations that we need to make, and we need to actually understand what they mean, right? So Python is interpreter based. Python is also object oriented based, right? Or it supports object oriented concepts, right? So what it means is that we can actually define classes in Python, and this is something that we are going to cover later, in one of our modules. So we can define our classes, and we can inherit classes, and anything which is supported inside the object oriented programming concepts, we can do all of these within Python, right? um, and these are the primarily two things which we need to actually take away from the definition, right? It is mostly Python is mostly used for scripting, and it has been really adopted well by the data science community. So what has happened is during the last 5 to 10 years, Python has really picked up pace in terms of being adopted by any of the use cases in the data science community, right? So your whole uh, libraries which are uh, which are the core of Python, things like pandas, numpy, and matplotlib, they are all developed or as packages of Python, and these are primarily used to do your data processing work, or anything that you want to do primarily with data cleansing, or data manipulation, exploratory data analysis, or if you want to do charting with Python, right? So we have uh, e- some of these packages which are available in Python, right? So what we have taken away from this introduction is Python is interpreter-based language. This is not compiler-based. It also supports object-oriented programming concepts, and we have our we have a lot of packages which are available in Python, which is primarily used for data processing, and it is one of the most common data uh, processing, or you can say languages which are used for any kind of a data processing. uh, the other language of choice, which is kind of compared with Python, is R. But then R is mostly used in research projects, and in the industry, mostly for the end user related products where we need to actually deploy something for end users. Primarily Python is used. So that is what uh, we have for the introduction for Python. Moving on, there are different versions of Python available in the market right now. It started with Python version 2, which was published in the late 2000, and this is how it all started, right? Now, can anybody tell me as to what different versions of a software are? What do you mean by a version?
Maybe futures were updated version to version.
Anyone? Yeah.
Futures may be updated from version to version.
Just added the new free flow in the version to version precision.
But what exactly is a version? Like, what do you mean by a version?
Mm,
So what happens in case of softwares is, I mean, any software for that matter, if you take Windows, right? Uh, it was not made at once. It was created and then it was enhanced over a period of time, right? And every now and then, when a new enhancement comes in, which is stable enough for the users to use, they release the software. But then that is not the end of the software development life cycle, right? They continue to further enhance it so that they can add new features to that software, and this is a never ending cycle, right? So we had Windows 3, then we came up with Windows Microsoft came up with Windows 95, 97, 98, Windows XP, Windows Millennium, and Windows 10 for now, right? So all of these are different versions of the software, right? Anything which is stable enough for the end users to use, they name it, or they give a number to that software, or the state of the software, and that is what we call as version. So when we are talking about Python 2, it was published in the late 2000. What we are saying is, at that point in time, whatever stable version of Python was available, they published it and they called it Python 2. They named it or they gave it a number or a version number. And that was the best available or the most stable available Python version that we had at that point in time. So Python 2 is what came out in 2000. Now, since like I said, any software it goes through its own cycles of improvements where new features are added and new libraries are added. Python also went through the same cycle, and it is still continuing to go through that cycle, right? So uh, after Python 2, what came out was Python 3, and Python 3 came out, I think, yeah, somewhere in 2008, and it has been, yeah, it is still pretty old, right? Python 3. It came out in 2008. You may be just wondering, right? What does it mean for me, right? There was Python 2, there is Python 3. What should be my takeaway? Because there are like so many versions of Python available for now, right? So think of it this way, right? Python 2 came out in 2000, right? And Python 3 came out in 2008. Now, anybody who may have used Python 2 from 2000 till 2008 may have developed using Python 2. Now, after 2008, Python 3 came out in the market, right? So, anybody who is developing a new software after 2008 has two choices: either use Python 2 or use Python 3. But what about anyone who has already developed a software using Python 2, somewhere in 2005, let's say? Now, that person needs to continue to use. So that person has two options, right? Either continue to use Python 2, or if you want to really want to use Python 3, then the person will need to actually migrate all of this code from Python 2 to Python 3, right? Why so? Why is that required? Now, that is required because Python 3 may have deprecated some of the features which were available in Python 2. This is what happens, right? When you enhance the software, you not only add new features, but then there are a few features or packages or functions which you do not think is important or relevant enough. You also turn them down, right? Or deprecate that, or bring them down, right? So in that case, any software which is working or which was developed on Python 2, using Python 2 and is working fine in version 2 may not work in Python version 3 or any other version. And that is why it is very important for us to actually know which version we are using and which version we should be using, right? So, and at any given point in time, you will have multiple versions of the same software available. It totally depends on your need. What is it that you want? If you look at it even further, what you will notice is after Python 3, you have Python 2.7 listed. Now you must be wondering as to when you already have Python 3 available, then what sense it makes to release Python version 2.7 after you have already released Python 3? So think of it this way. Anybody who has already developed his or her application in Python 2, if they do not want to migrate to Python 3, then they should be also given a choice to continue to use Python version 2. And actually, Python 2.7 came out in the same year as, if you look at this year, it came out in the same year, 2008, when Python 3 was released, right? So both Python 3 and Python 2.7 were released, but then the motive of releasing these two software versions were different. Python 3 came up with new enhancements, new extensions. Python 2.7 was for existing Python 2 users. So that is with the versions, guys. How do you check which Python version you have installed, right? So if you do not have Python version installed right now, you cannot run that command. But if you already have it, then this is what you can do, right? So you can search for Anaconda. You can search for Anaconda prompt and just click here. When you click on this link, you will get to the terminal, Anaconda terminal, and here you can just write Python minus minus version, and it is going to show you what Python version you're using. So I'm on Python 3.7.6 version right now, and this is what it is showing me. And this is it. I can very well say that I'm on Python 3 right now, and the latest version is 7.6. So I'm just minimizing this screen for now, and this is all about the versions, guys. If you have any questions regarding the introduction and then the Python version, then do let me know, and otherwise we will continue further.
No, that's fine.
I'm good on that.
Okay, all right, perfect. So just take a note of this command for now. If you're taking notes, Python space dash dash version, or you can always refer to this video, which I'm going to share to look at it later. So this was with the version, right? How about your download? Is that complete by now?
Yes.
Okay. So can you, since I've already installed it, I'm not going to install it again, but then can you guys double click this and start the installation process so that we can just make sure that you all have Anaconda installed after the session ends. Click on this. This is like installing any other software. You can just click on continuing. Next, I agree. Select whether you want this to be installed just for you or for all the users. It is totally your choice. Then select which folder, which destination folder you want this to be installed into, and you can just click on next. I'm not going to do this because after this is going to install, start the installation process, and I already have Anaconda 3 installed right now. So just start with that process and keep letting me know how it is progressing. It may take 5 to 10 minutes for each one of you to actually install this, but
Do
it
you want me to share?
not really, unless you are finding or encountering any issues, does not really required. But then
Okay.
yeah, just keep letting me know on the progress of it. We would want to make sure that everybody has this environment set up so that you can actually work on this after the class as well.
So in advanced option, do I need to select the both the options here? Add Anaconda 3 to my path environment variable and register Anaconda
Yes,
3
yes,
as my.
yes. Please do that. I will let you know why that is important. So it will not let me move forward because I already have Anaconda 3 installed at this location. So I'm not proceeding, but then you guys proceed and do let me know what are the issues that you're facing.
Yeah.
So once your installation starts, it may take around 5 minutes for you to complete this. Has it started for anyone by now?
So it was still installing.
Okay, all right. So it has started, right?
Yes.
Yeah, okay, perfect. You should be good in 5 minutes now.
Meanwhile, I have a question. So,
Yeah,
will you be
sure.
covering the TAPPy module as well?
TabPy is the Tableau Python integration, right?
Yes.
Yeah, I'm not planning to because I did not put that in this one, but I will be actually starting a course on Tableau, and that is going to get covered there, the TabPy integration. I
But we can have a little bit session about it, so that
Yeah, we
can.
can definitely talk about it. It's a session which will include which will require us to actually talk about not just Python but then Tableau as well. But then most of it is actually done inside Tableau. There's nothing when it comes to TabPy integration. There's nothing that you do within the Python environment. So it is more of a Tableau specific or a Tableau relevant thing than a Python relevant thing, right? But you can only do that once you know how to write, the correct syntax in Python. So
Right.
Python, knowing Python is a prerequisite. I think once we are done with that, we can briefly cover that as well. We can keep one session for that. That's not a problem. And I think I will probably take a note of it as well.
Yeah.
So all of these are going to be additional sessions, guys. Even if we are not covering it here, either we can schedule additional sessions for them, or what I can do is I can share with you guys pre-recorded videos that you can go through. But let us first finish Python because that's a prerequisite. If you can write syntax yourself, you can do TabPy. There is no problem in that.
Yeah.
Okay.
So in the meantime, has the installation started for everyone? If it has started, then we can continue to discuss something about Anaconda right now.
Actually, we can start to discuss about it.
Sure. So let's start discussing. In the meantime, the installation will finish, right? It has already started. It'll take around 10 minutes. So, what is Anaconda? What is it that we're trying to do, right? So there are multiple ways in which we can install Python, right? But since most of us are, newbies, right? It is our first time that we are trying to install Python. So we're not going to do it ourselves, as in we are not going to install Python executables ourselves. Uh, Instead, what we are going to do is we are going to install Anaconda Python distribution, right? This is what is installing on your computers right now. So what it does is it takes care of everything that needs to be done in your computer to create a Python environment, and it is just a setup that you need to execute, right? So this is like a wizard, right? You download a executable, and then you select some of these options which the Anaconda Python distribution provides to you, and once it is done, your environment is going to be ready. uh, so what it includes is it includes all the packages which is available required for you to actually download and install in your computer, so that you do not need to do it manually using command prompt. So it includes all of these packages. It also creates the environment for you, right? So somebody asked me whether I should check that option to uh, set the environment variables or not, right? So all of these, if you install uh, Python manually, then you will need to do all of these yourself. But right now we are not doing that, right? We are using Python distribution, so it becomes very easy for us to actually download and install it. So then there are a few other things, right? Once you install Python, then you will also need some of the integrated development environments, right? So you may have heard of Jupyter Notebook. We just saw. You may have heard about Spyder or PyCharm, right? These are some of the integrated development environments in which we actually write these code, uh, whatever code we need to write in Python, right? So how do we install them? We will need to install them manually and separately, right? So installing a Python environment and all of these environments, um, and then the integrated development environments, the IDEs, as well as setting up the environmental variables. All of these are very time consuming, cumbersome, and manual processes. And if what Anaconda lets you do it, it packages all of these together in a single executable file. So installing and making this environment ready for you is going to be much easier, and that is what Anaconda does for you. So right now, your all the Python packages are installing in your machines. Your integrated development environments are also executing or installing in your machine, as well as your environmental variables are also getting set right now. So once this setup executes, and you exit, then you can straight away write or start writing your program code, your first program code in Python, and then you can start executing them. And that is where Anaconda comes at rescue. It actually lets you install or create an environment very easily. You don't have to worry or about doing them manually because doing them manually is a very cumbersome process. So you can probably read through this. This is not going to be a difficult read at all. But then I just want to let you guys know as to why we used Anaconda and why we are not actually doing or installing Python ourselves and manually. So that is the reason, right? Anaconda latest version is 3.7, and that is what you are installing right now. Then moving on, what is Jupyter Notebook, right? So Jupyter Notebook is one of the very common integrated development environments that we use right now. I'm sure, may have, if you have heard about Python, then you may have definitely heard about Jupyter Notebook as well. This is one of the most common available integrated development environments that we use for Python. Uh, what you see right now is Jupyter itself. So I will let you guys know how to start Jupyter Notebook once again, once your Anaconda prompt or on Anaconda package is installed. Um, and I will also show you some of the other integrated development environments and how to actually open them. So once your Anaconda installs, right, which should be within a couple of minutes, what you can do is you can write search for Anaconda, and there are two options that you'll get here, either Anaconda prompt or Anaconda Navigator. So you should click on Anaconda Navigator, and it is going to take around 30 seconds to open the Anaconda Navigator, and it'll show you what all packages has been installed and what all IDs, the integrated development environments, has been installed on your computer. So let's just wait for the Python navigator to start, and it should be, yeah, it is already loaded, right? So this is how the Anaconda navigator looks like. You will most likely not be loading it uh, you know very frequently. This is only for just looking at the environment. You don't necessarily need to actually look at it uh, you know very frequently. So if you look at what all appears here, you have Jupyter Notebook here. This is the same notebook that I already have open. How you can load Jupyter Notebook is from here. This is one of the most common environments that we use, or integrated development environments that we use to write code. The other one is PyCharm. I'm sure you must have heard this name as well. So if you want to load PyCharm, we can load it from here. And there's also another uh, environment which is called Spyder. We can use Spyder as well. So what I will do is I'll quickly launch and show you Spyder and Notebook for today. PyCharm is something that we are going to cover later. We're not going to cover Python uh, until we reach the end of the course. The very last module where we are going to actually, let me just show you. So the very last module, which is going to talk about API development and deploying your own API onto a cloud server. This is where our PyCharm introduction is going to happen, because we do not need PyCharm anytime before we reach this stage. So we are just going to introduce that at the end of the course. Right now, I'm going to show you Spyder and Notebook, right? So let me launch Spyder. Now, there are two ways you can launch Spyder, right? You can just write Spyder in your start menu, and you can search for Spyder, and you can just click here. That is one. And if you have your Anaconda Navigator open, then you can just click on launch button as well. Both of these are going to do the same thing. So let me quickly show you how to launch Spyder.
Manish, just a quick question.
Sure.
Which is the best IE which we are using when we are working as a professional?
So totally depends as to what your need is, right? And then there is no right or a wrong answer to this, right? If you are developing an API, then you will definitely need PyCharm. There's no way you can deploy, like, create, test, and deploy your API using Jupyter Notebook or Spyder. This is where these tools are not really you know very well capable of doing these. You will need PyCharm, but then if you really want to do some kind of a analysis in isolation and be able to share them quickly, then Jupyter Notebook is the way to go. With Jupyter Notebook, so every IDE comes with its own features, right? So Jupyter Notebook is something which is supported in the browser, right? If you look at this code which I was referring to so far, this is open in Chrome, right?
Right.
And it is easy for me to actually share the screen. I have some lines of code which I'm going to show you, very shortly. It is very easy for me to actually refer to this, open this locally without me having to, install a lot of uh, Windows-based applications, and actually I can run it in a browser. So the good thing is I can even run this on a phone. If I really need to. It will not give me any issues and stuff like that, or a tablet, any mobile device, by the way. So that is where Jupyter notebook comes into picture. It becomes very easy to run your code. It becomes very easy to share your code, right? At the end of the day, what I need to do is I need to just share this file, which is I had already showed you Python introduction dot ipynb, right? Something that you can download from your dashboard once the access is correctly assigned. So that is the benefit with Jupyter Notebook. But if you have a preference where you want to work on a Windows-based application, and you do not actually need to primarily share it with people, and your need is not to actually open this in a mobile device, or a laptop, sorry, a tab, or a phone, then you can probably work in this kind of environment. It gives you a feeler of a Windows application, and actually this is a Windows application. So you can actually write your code in this environment, and then you can execute it, right? So what I can do is uh, write a small line of code. My first Python code.
Okay, it's like I'm working as a data scientist and all. I'm working some data analysis. And so that Spider will be the good environment to work for me.
You can do either of them, right? What happens is everybody develops for some reason or the other, an inclination towards using either Spyder or Jupyter Notebook, and you can just use either of these. It is totally fine. If you do not have a compulsion, or if you do not have a requirement of being able to execute this code in a browser, then you can just use Spyder. So with Jupyter Notebook, you have this added flexibility. So people who need that flexibility, they will probably use Notebook. Otherwise, you can continue to use Spyder as well.
So here is also we are running code our line by line. Right?
Right. It totally depends, right? So right now we just have it'll go down, from top to bottom, of course, unless you have defined your own functions, or if you have written the code in a modular structure, which we are going to discuss in the second class onwards. Uh, if you have not written your program in the modular structure, then it is going to run from top to down. So your first line of code is going to execute first, and after that So this is my first Python code. This is my second, right? Python code. If I just execute it, you'll see that this is running top to down, right?
Yeah.
So this is one environment. I mean, what I will say is you should, even if you develop an inclination towards using one of these tools or in integrated development environments, you should still continue to be uh, familiar with the rest of the IDs as well, right? You should not be getting into a state where you only know one IDE because you really do not know. In your present organization, people may be using Notebook, but in your organization that you may be willing to join or you interview with, they may be using PyCharm. Then at that point in time, you should not be caught in a situation where you know nothing about PyCharm. Even if you have not used it extensively, you should still know how to use it. That is what the whole idea is.
Okay. So
So
Python is basically when we need to create some APIs and need to test with Postman, and so we are using that Python, right?
PyCharm, at that point in time, we need PyCharm. Otherwise, we are good. PyCharm is only when we need to work with uh, APIs or create our own APIs. Now, this code that I've written here, this can be written inside Jupyter Notebook. This can be written inside PyCharm as well, right? But
Yeah.
PyCharm would be too heavy an application to use for any such application, which is very basic. So ideally, we should develop some understanding, where we should be using these tools wisely, right? And not actually overdoing stuff just because we have developed a preference for it, right? And that is why I'm saying you should at times use Jupyter Notebook, at times use Spyder, and actually understand or develop understanding for yourself as to where you should be using what, right?
Right.
So yeah, so with time it'll come easy, but to begin with, you should not get into a mindset where if somebody tells you that Jupyter Notebook is better than Spyder, then I don't think you should buy that idea. Every tool has its own limitation as well as added benefits. At any given point in time, you should be familiar with what tool offers what features, and you should be using them accordingly. So this is how to use Spyder. You can save the code and you can create new as well. You can save it wherever you want, and let me. So yeah, so first program, right? And what it is going to do is it is going to save a file. We'll quickly check. So this is the file it has created, right? First program. If you look at the properties, it says .py. So first thing that we have known here is the extension, the file extension for any Python code is .py, right?
Right.
And if you're taking notes, then you should probably take a note of this as well. Python programs have extension py, which stands for Python. But at the same time, if you create the same program in Jupyter Notebook, then it has a slightly different extension. The extension is IPYNB. Python Notebook, NB stands for notebook. It is not py. So the thing is that if you create a file or a Python program in Spyder, you will not be able to open it inside Jupyter Notebook and vice versa. So you should be really sure, and unless you copy paste the code by opening the environment, the file itself is not something that you can double click and open. So that is what I meant when I said you'll not be able to open the code in the other environment. So this is one uh, piece of code which is written in Jupyter Notebook. It has a different file type, it has a different extension, and this one is saved using Spyder. So it has a different file type, it has a different extension. You'll not be able to open them in the other application. So this is how you actually start Spyder, guys. I think this is very simple. You have the same standard options, right? You can open a file, locate using Windows browser, and you can open a file from here. If you have already saved a program, if you want to save it, you can save it from here. You can do file save as option, and that ways you are given multiple tabs in here, so you can have multiple programs open simultaneously, and you can just have different logics built into different tabs, and that is how you can actually continue to use it. So that is with Spyder. Explore this a little, and do let me know, guys, what issues you run into or what kind of questions you have, and we can take them up as well. What I am planning to do is, for some of the modules I'll be using Spyder. For the rest of them I'll be using Jupyter Notebook, so that you get a hang of or a feeler of both of these. And my honest recommendation to you is, never ever develop a inclination towards using either, because that is not going to work in the best of your interests. And your interests are that you should be knowing as many, like you should be at least familiar with as many IDs which are popular in the market, right? And should not be actually sticking to any of these and not knowing the rest of them. So I will continue to use Spyder for some of the modules, and what I need to now show you is how to launch Jupyter Notebook, right? So again, two ways. You can launch it from Anaconda prompt, or Anaconda Navigator, which is this one. You can just click on launch. The other thing is, if your Anaconda is installed fully, then you can actually write Jupyter Notebook, and you can just click on here. So when you click on this, I will just run through this process again so that you know for sure. When you click on this, then a black window will open, a command prompt will open, and it'll, where is that window? Yeah, so this one. So it opens the Jupyter Notebook inside inside a browser window, right? Whatever your default browser is, it'll just open that default browser and open Jupyter Notebook in that browser. Like I said, Jupyter Notebook runs inside a browser, so it'll open that browser and start Jupyter Notebook there. But you you can only use Jupyter Notebook till the time you can leave that window open. The moment you close it, your Jupyter Notebook is going to close, right? So whenever this black screen opens, which says Jupyter Notebook, you can just minimize this and then just go to that new tab which has opened here inside Jupyter Notebook. So this is the environment of Jupyter Notebook. What you can do is you can create a new Python file, you can create a new folder, and you can create your program files inside that folder. What you can do otherwise is you can also see the Jupyter, inside the Jupyter Notebook, you see the whole folder structure as well, right? So you can actually navigate through this folder structure and open an already created program file as well, right? So what I'm going to now do is I am just going to create a new Python program the way I created in Spyder a moment ago. So I'm just going to click on this option, which is new Python 3. And then this is the environment that we have for Jupyter Notebook, right? So this is the name of the file. Like I told you, you can name it for whatever you want this to be. So first program using Jupyter Notebook. Okay, so this is my first program written in Jupyter Notebook. I renamed it, and then what it does you is it provides you different cells, right? And you can write as many number of lines of code in every cell that you want, and you can keep adding new cells. So if I want my program to have 5 lines of code, then I can keep adding cells, and I can keep adding as many cells as I want. If I have a few extra, then does not really matter. I can delete a few if I do not really want. So what I will do is I will quickly write a simple program here, or a single line of code, which is my first line of code in Python. And how do I execute this? So I can execute it by clicking my cursor, putting my cursor inside this, or highlighting this cell, and just clicking on run. So when I do this, the good thing is at the end of every cell, it is going to show me the outcome of the line of the code, and it is just printing my first line of code in Python here. I can copy paste this, put this into another cell, and I can execute it from here as well. So now this is selected. I can click on run again, and this is printing whatever I want to print here, which is my second line of code. So writing the program code, saving this program file is going to be much easier. The other good thing is you are not using any Windows based application, so this line of code is going to execute much faster. And if you really want to share this with anyone, then you can just share this file, which is first underscore program underscore using underscore Jupyter underscore notebook dot ipynb. You can share this file, email this file to anyone, and then that person can open this file in their Jupyter notebook to execute this code, right? Let me try and show that to you as to how we can do that. So let's assume that my program has only 2 lines of code, right? So I will just delete these lines of code, and then I will save this, and let's say I close this, right? What is the name of the file? First program using Jupyter Notebook. So I'll just close this, and when I close this, you will see that it got saved, right? And I can actually see it here. How do I open this? I can just click on this, and it will open in another window. This is it. I can run these individual cells as well, and to do that, there is a shortcut, right? Instead of clicking on this button which says run, I can just click on or use keyboard shortcuts, which is control and enter. So I can just do a control enter. You must have seen the screen just blinked for a second, and this is when the code actually ran again. So there are these 2 ways in which we can actually run these lines of code. So that was for the introduction of Jupyter, guys, and with this I'm kind of done with introducing to you guys how to actually start Jupyter and write your basic lines of code and save them and open them again. So I've just done that, and I also showed you how to open Jupyter Notebook, write a few lines of code, save and close the file, and then open it again. So with this, you will be able to now open uh, this introduction Jupyter Notebook, which I was showing you, which has all of these instructions and then the introduction that we just talked about. So one thing which is what you can do is if you do not have let's say Jupyter Notebook, then you can install it yourself as well. But then for us, since we used Anaconda Navigator to install the whole package for us, Jupyter Notebook comes as part of that package. So we didn't have that issue where we were required to launch or install this on our own. So this is just an additional information for you. You don't necessarily need to do anything in here. It is already taken care of. Uh, the commands which are mentioned here, conda install Jupyter Notebook and pip install Jupyter Notebooks, are commands to install it manually, which we did not want to do in our first class. Uh, so, so you don't need to worry about it. You can still, as a reference, know as to how to install Jupyter Notebook. We have already done this, launching the Jupyter Notebook by searching for Jupyter Notebook here. So this is already covered, guys. What it is showing you is it'll open, a command prompt window, and it'll open localhost 8888 port in there, and we just need to leave that open so that our Jupyter Notebook server runs locally, and we can actually run our commands inside Jupyter Notebook environment. So that is it, guys. That stuff that we needed to cover for today. Do let me know if your installation is done or not.